Hello, my name is Vivian. I am the CTO co-founder of Diligent Robotics, and today I will be talking a little bit about how we at Diligent have launched socially aware mobile manipulation platforms in the healthcare setting, and just some of the key takeaways, challenges, and lessons learned for this group to take away and think about how to apply that in your research and labs and going forward. Okay, I thought it might be nice to actually set the setting to give a little bit of background about myself really quickly to give context for the rest of the talk. I see myself at a high level as an academic and a first-time startup founder. I started my career in research where some of the very first mobile manipulation platforms you can see here were on the PR2, Mecha Robotics, and really focused on teaching robots how to learn from people, human-robot interaction, how to manipulate the environment using multimodal sensory information. I started Diligent back in 2018 with my PhD advisor, Dr. Andrea Tamaz, where we decided it was time for robots really to go out into the real world and help people. We saw that the technology, the hardware was getting cheaper than ever. A lot of the tools that we were using were no longer things that we would research about. It was things that we were using to do research about. And we saw that we just, in terms of the introductions of our papers, we saw time to actually do the impact that we say in all of our papers, which is robots hitting the real world and really helping people and making a difference in their lives. So I need to give the obligatory spiel about Diligent Robotics, what we do, why we do it. So Diligent is a robotics company focused on supporting frontline clinicians in healthcare. We're based out of Austin, Texas, where we build robots directly and ship them to our customers. So why do we support our frontline healthcare? If you think about it, nursing is a huge and growing need, where the World Health Organization has estimated that by 2030, you need an additional 9 million new nurses in order to prevent a shortage. Why does this happen? Well, nursing is the backbone of healthcare. However, nurses are extremely, at this point, a lot more burnout is happening, as well as the aging workforce. If you look at the United States alone, we expect 500,000 nurses to retire just this year. And we have to figure out how we can backfill these, the clinicians to be able to support and gain those nursing licenses to make an impact and difference. So the tragic thing is that the stress and burnout has actually always been around, and the COVID has only accelerated this into a crisis moment. Why does this happen? Well, if you think about it, nurses are the backbones of a healthcare system. They are the interaction points between all the different departments like lab, pharmacy, central supply. When those departments have some deficiencies, the nursing staff has to pick that up because they are the frontline support. What ends up happening is that if a lab doesn't have a technician that day because they're short-staffed, it doesn't mean that their patient is not going to get their labs run. It means that the nurse is now going to hand deliver that specimen to that lab in order to make sure their patient gets the care that they need. As a result, a nurse now not only leaves their unit, which is incredibly dangerous, away from their patients, but they're also now spending a lot of their time fetching, gathering supplies when they could be spending their time with the patients and adding to their already long 12-hour shift days. If you look at the statistics, it shows that 30% of nurses in the United States spend up to 30% of their of their time fetching and gathering supplies, something that you don't need a nursing license to do. We at Diligent really focus on human-centered design, and we've spent thousands of hours now shadowing nurses and clinicians to understand the problems. And we've seen firsthand how busy nurses are, where they can't even step away from their shift to get a coffee or even eat lunch. And this just contributes to the burnout problem. This is why we've built Moxie. Moxie is our point-to-point delivery robot that's working in hospitals today in order to help frontline staff be able to offload those burdens of transporting things like specimens to lab, pharmacy from medication from pharmacy, as well as lightweight equipment from central supply. And it really allows the hospitals to think about the robot as an extension to their team and really think about how robot human teams can change the way they think about staffing levels and really be able to emphasize and help them as they continue to take care of patient care as it gets harder and harder. So here's a video of Moxie. You can see that doing a point-to-point delivery task, you see that the robot has to navigate through a door. It actually just opened that door, go down the hallway where there's people, there's clutter in the environment, and the robot will actually go to a pickup point where the staff will badge in securely and load the robot with a specimen. And when the robot gets loaded, the robot will then go and take this to lab so the nurse can stay in the unit and not have to run that task. We've developed Moxie, and Moxie's actually been in hospitals. Some of our oldest robots have been there longer than a year, and we already hear some fantastic feedback from the clinicians and staff of how the robots are impacting their day-to-day. You hear quotes from staff about how they didn't even realize how much running they were doing until the robot started to take away some of that running, and they realized that they're saving so much time. I've talked to house supervisors where they used to walk 20,000 steps, and with Moxie now they only have to walk 10,000 steps, which is already a huge impact in terms of their health and well-being. Now that hospitals have integrated Moxie into their workflows, it would be just devastating for them to remove the robot, because then they have to figure out who would run those tasks now, and the robot would no longer do it. And there's also a social aspect and element of the robot, which is really interesting to see, where Moxie really just brings a little bit of joy to the already hard days that the nurses and staff have at the hospital. We've heard stories where a nursing manager, for example, will be giving actually a presentation and talking to her staff about the day, and then the robot rolls by, and the staff member, like the nursing manager, pauses, looks at the nurse, and even looks at the robot and says, "I just love that robot," right? Like pauses the entire meeting and then goes back to their day. And that just kind of highlights a little bit of joy that the robot brings. Another fun story that I like to talk about is one of the nurse managers told us there was a doctor that was having a rough day, and they were able to walk up to Moxie. So Moxie make these meeps and beeps actually as part of the routine sort of task planning. And the doctor actually walked up to the robot, patted the robot in the head, meeped back at the robot, and was able to bring that a little bit of a smile on her face before she went on for the rest of the day. So these are some of the stories. Yeah. Perfect. I think I caused echoing with my settings, so sorry, folks. Okay, so we will go ahead and continue. So essentially what we've heard from the field with our robots is A, how much work the robots are doing, steps saved, and then two, just a little bit of joy the robot's able to bring, given that the fact that the robots are really truly integrated as a teammate for them. Okay. So before I dive into some of the technical challenges and learnings, I thought it would be nice to also set the stage in terms of the fact that Diligent Robotics is a startup. It's fundamentally different from other institutions and organizations, larger companies, in terms of how we might tackle this problem and some of the learnings from it, right? You have large companies and organizations that might have more resources, have the ability to have parallel efforts, multiple platforms even, and as a result, that's just fundamentally different in a startup, where we have really just one shot to get it right and avoid all the pitfalls and think about resourcing from a different perspective. So setting the stage there, I thought I'd just talk about startups, right? We as startups have to do more with less. And in order for that to happen, it really allows us to think about what trade-offs you have to have in order to bring the product that you need to your customers. What essentially is a double-edged sword. If you think about from the positive perspective, it actually allows us as a company to really narrow focus and have a single mission in terms of delivering our product to our customers. We don't have competing priorities, and because we're small and agile, we can actually pivot the company quickly and to focus on what is necessary. So even though we have less resources, we can actually move more nimbly than some larger organizations. So setting the scene, startup, limited resources, getting robots to our customers in order to make an impact in healthcare, and how are we doing it? So we thought it might be interesting to go into this presentation by actually going over a key feature that Moxie does importantly in the hospital in order to navigate, which is open automatic doors. So here's a video. What do I mean by opening automatic doors? So here's the video playing. Hopefully you'll see where Moxie is in a hospital, one of our hospital partners, where the robot perceives the environment. So here is a badge scanner. The robot then has to generate legible motion around in order to scan that badge reader. From that, you'll actually see that the door opens, and the robot has to detect that that door is now open and navigate through it before the door closes. Here's another video, a little bit different, so you can see that it's not just scanners that the robot has to interact with, it's also buttons. We have to physically actually touch the buttons and push on it in order for the robot to actually operate these doors. So here the robot pushes on the button, has to detect that the door is open, and has to quickly go through the door before the door closes on it. And here's a fun one, similar, but thought it could be interesting to show because the distance from where the robot has to push on this button from where the door actually is almost 8 meters. So it just shows you some of the variance that the robot has to be able to deal with in terms of different hospitals. What I just showed you were 3 different doors from 3 different hospitals. And so here, the robot pretty much has to book it in order to make it through that door in time, where you can see the door is already starting to close. So here's some of the videos to just give you a sense of how the robot is able to navigate hospital-wide. So what needs to happen in order to actually solve this problem? A lot of pieces. You have to perceive the device. You have to perceive the state of the door. Is it open? Is it closed? You have to generate accurate and fast manipulation, as well as navigate quickly through the door before it closes back on the robot. Oh, and also, guess what? Be safe around people. The hallways often have beds, people walking through it, and the robot has to share that space with people. So you have to be able to dynamically interact and be able to react to that. So what makes this challenging and also what makes this easy? I thought I would focus on what are the things that go in the robot's favor in terms of the healthcare setting. One, like ADA compliance is actually a helpful thing, where the robot, where hallways have to be a certain width. The fact that we even have automatic doors to begin with, right, simplifies the problem for the robot in the system. We actually do have a slight ability to modify the environment. You saw in the videos that we have a fiducial. We've picked and chosen which technical challenges to solve, and perception, where if we can throw a tag on the wall, is perfectly fine. The hospitals are okay with that. So what makes this hard? So there's obviously a lot of things. I'm just going to highlight a few. The environmental variance is one where I'll show you some pictures actually about just all the corner cases that we're encountering that really, if you think about in your lab as you run your experiments, you actually feel pretty good, right? You added some noise, you added some clutter, you tried some different scenarios, you show your robot generalizes. But then when you start pulling it into the real world, you realize that the number of things that you have to vary and experiment and test with are just massive. Just in the door situation, door configurations, type of badge button readers, the timing of the doors, the configuration of the hallways, they all are things that can change and vary. And you start to get, if you think about trying to actually test for that, it starts to become intractable. I mentioned already previously, people make this incredibly difficult. It's surprising how quickly people get used to Moxie in their environment, and they get impatient. And so we've seen where people will cut the robot off or get impatient that the robot's interacting with the device, and even just throw their body in between the robot and the button. And so we have to be able to handle and deal with these in a safe manner around people. Picture speaks 1,000 words. So I thought throw up a couple of images from hospitals to just demonstrate a little bit of the environmental variance that I was talking about. So here are some badge buttons from our hospitals. You can see these are like Moxie's bread and butter, very standard, not very much clutter, pretty straightforward. So it's like, okay, we can handle these, right? And then you start to see some of the corner cases, right? So here's a button. There's some obstacles around it. And in this case, this button has actually changed visually. It looks really different from the previous ones that we've seen at hospitals. We're like, okay. And then you see situations like this, where it's almost like find Waldo. Can you find the badge button reader? Some ones like, for example, in the top left, I'm just amazed at the creativity when I go to our hospital customers of where you can even install some of these devices. So you can see on the bottom left, right, you have a device that's really close to a cabinet, which means to be very careful in terms of your interior path planning so you don't actually hit that cabinet. My favorite one actually is the bottom center one, right? The hospital must really care about infection control and efficiency. So every time you open that door, you better also hand sanitize. And so these are the challenges that we have to solve and figure out how to deal with in the corner cases. But even if you say, okay, great, these are static obstacles, we can program around it, we can generalize to it, then you throw more people into it. And here's now beds, IV pumps, crash carts that all are blocking the devices. And now we have to think about, well, how do you educate them? And how do you make sure that these things are not blocked because they will prevent the robot from navigating? So these are just some of the challenges and highlights I thought I'd share today. So how do we solve this problem? There's obviously a lot of different approaches and techniques. I'm only going to highlight a couple of them here. First and foremost, it should be obvious, like human-robot interaction is super crucial in this environment. You really have to think about how the robot's behaviors, how the communication to the staff really impact how they will accept the robot, how they will help the robot out in these situations, and make sure not to block key things where it's clear that the robot needs to be able to interact with. And it's amazing how much you can get away with it when you have a cute robot, right, that occasionally does dumb things. And so that sort of aspect of it is super crucial when you want to think about putting robots around people. This next one should not be a surprise to this crowd. The sheer amount of QA that you need to actually get the system out into the world is just unfeasible, intractable, right? You have to think about ways to simulate the environment, have to think about ways to get those corner cases and train your system so that you don't encounter it for the first time and have the robot not understand how to deal with it. And finally, this one might be a little bit more novel for this group, sort of MVP, minimal viable product. We really have to think about what you spend your time and your resources on. You are going to encounter all these corner case and situations that over time, you'll gain more and more of a data set, more and more of what the robot needs to tackle, which means you really have to think about what is the minimal thing that the robot needs to solve today to provide value to your customers. So we often think about the framework of crawl, walk, run. What is the bare minimum crawl to get this to our customers, and then continue to build on top of that until you're really running on a particular feature. And this is the approach we took for Moxie being able to open automatic doors. And now the robots in our fleet have opened thousands of doors successfully, which is exciting moment for us. So another thing you'll notice that in order to solve this, even this one problem of being able to go through an automatic door, you really have to have all the components of robotics, right? Perception, manipulation, navigation, simulation. I didn't even talk about our cloud infrastructure that's necessary in order to have the robot share this knowledge between itself, as well as a lot of testing. And so in order to solve all these components, I can go into each one of these, but spoiler, teaser, I'm not going to. It's a lot of it's proprietary information. And so there's a little bit of a shameless plug. We are hiring for all of these expertise to join us and learn more about how we do take our approaches from a technical perspective to solve these. I thought I'd finish the presentation just to talk a little bit about how COVID has impacted hospitals and how has it changed over the past few years in terms of the landscape for robotics and healthcare. The first one I highlighted earlier in the talk was just the problems that were in the healthcare before continue to be a problem and have just gotten worse. For example, nursing burnout before the pandemic, there was a turnover rate around 16%. Now in 2020, that turnover rate has jumped to 27%. A quarter of new nurses who enter nursing all drop out within the first year when they realize the challenges of all the work they have to do on top of the patient care that they learned in school. We've also seen that in order for hospitals to deal with the influxes and changes in the hospital, they have staffing agencies where they have traveling nurses in order to help deal with that variance. That exploded in the pandemic and really has become unsustainable for hospitals that they have to figure out whole new staffing models in order to account for the financial budgetary concerns of having to not have a workforce that is large enough that they can continue to sustain patient care. And this final one is actually interesting. I thought I'd talk about UVC cleaning in hospitals. This is something that when the pandemic occurred, a lot of robotics companies said, okay, well, the pandemic is here. How can I help? How can we make an impact? And UVC cleaning seemed to be a very straightforward option. We actually did something similar. We, in the pandemic, as it started, thought, hey, let's go and clean the hospitals, help them deal, see if we can have an impact that way. And the interesting thing from that was a lot of our hospital customers were just like, no, actually UVC cleaning is fine, but we already have our protocols where we use wet contact wiping to be able to clean our hospitals, and we have our process and procedures. What we need you to do is continuing doing what you're doing, which is deliver things across the hospital. And during the pandemic, all of the workflows that that were designed to transport things around the hospital just fell apart because you had units becoming COVID wards, not becoming COVID wards, you had to transport PPE, and they didn't have the time or money to suddenly install a bunch of pneumatic tube systems in order to handle it. And it was actually really interesting and exciting for us that we got to see Moxie make a huge impact for our hospital customers during this time, because it really allowed them to add new pickup points, new drop-off points, and really react dynamically to a very fast changing situation. So that, I believe, concludes a little bit of a teaser into what we're building here at Diligent, how we're doing so, some of the challenges. I'm happy to answer any questions that you may have.
Vivian, thank you very much. Thank you so much for a nice talk. And I would like to take some question and comment from the floor. Hey, you with hat.
Great talk. I had a question on particularly like the opening the doors and operating elevators. We've seen an emergence of other frameworks like OpenRMF to sort of automate, like integrate the whole IoT sphere into the operating environment in the robot. I see you've had to tackle some of the door operation manually, so maybe that's a deliberate choice in terms of lowering the barrier integration. But do you have any, could you speak about what other choosing your battles, or like on a technical sphere, that where you've had to make deliberate choices and either reducing or refining the scope, either from a technical perspective or from a business perspective?
Yeah, that's a great question. In a perfect world, right? Exactly. We would prefer to have an API. We'll just talk directly to the elevators. We don't have to solve that problem. What we saw was that was one that we couldn't make that trade-off, where not all the elevators are connected. If you think about all the players in that space, the time it would take to integrate and then deploy to a hospital, by then you're a year out and the hospitals won their robots months in advance. And so that was one that when we tried to make that trade-off, it didn't make sense. It doesn't mean that we're not exploring that in parallel, but we decided from a strategic advantage that was actually crucial to have the arm be able to interact with the environment. It just sped up all of the pieces that we really needed to do to tackle it. If we think about other pieces of it, I mean, we use ROS underneath the hood. And so a lot of the pieces that allow us to get up and running quickly was super crucial, and that was choosing our battles. We're now getting different components, just like every robotic startup company, and removing parts of ROS as we're getting more and more robust. But that really allowed us to go quickly at the start, which is we got Moxie out with our customers within 9 months of starting the company. And that allowed us to do a ton of research trials to understand what the robot should even do, which is huge for us. We wouldn't be where we are today if we hadn't done that.
Thank you.
Thank you. Yeah, please.
Hi, thank you very much for the developments that you do in this direction. I was wondering that in your talk, when you were talking about like when you want to open the switches and so on, how do you think the future development of hospitals should change such that, for example, they become easier, these kind of switches detectable by the robots by RFID tags and so on. And on the other hand, so this is the one part. And the second part is that you said that it's important to educate the nursing staff to not leave the stuff around as they do or whatever, because it's problematic for the robots. Wouldn't you say that it's better that the robot becomes more intelligent and navigates in these unstructured environments such that the human doesn't have the burden of thinking what the robot would like to do? Right? I would say that it should be the other way around. What do you think about this? Thank you very much.
Yeah, so if we think about the first question, there's definitely hospitals that are being built today, thinking about technology, thinking about integrations, the newest and greatest sort of elevators, which have APIs built for them. There's actually hospitals today for other robots that have been built with a lot wider hallways, interstitial hallways even for the robots to traverse to it. What we're just seeing is that it takes, when I talk to hospitals, 5 to 10 years to build a hospital. And then you have the hospitals in the rural areas that just can't afford to do that. There are some hospitals where they have a pneumatic tube system that they can send things all around the hospital. And there are hospitals that can't even afford that. And so when you think about those challenges, that's where it's really difficult to say, hey, you need to build your hospital to those specifications. But we are talking to different hospitals that are in that midst in building, and then it's a question of like, hey, what can we do to make it easier? And we do talk about hallways, automatic doors, door timings, right? These things, as well as different elevator APIs that would simplify it. In terms of your second question, yeah, we would love to be able to have a robot handle all the situations without having to have people help the robot. I think that is like if every roboticist holy grail, right? We've generalized, we've solved AI. The way that we like to think about it is there's a fine balance between what you can get people to do, and there's actually a lot of progress we can do with the technology that we have today until obviously everyone in this room continues to make a lot of breakthroughs and progress. And as a result, we can leverage the fact that we ask for help all the time, right? When you're in an elevator, you ask someone to hold the door for you. You ask someone to push on the elevator button. So we really think about leveraging HRI and a lot of these pieces to honestly solve what we need to solve today to have an impact with our customers right away.
Thank you.
Okay, thank you very much. And yeah, you with the white mask, you raise hand first, please.
Hi. So regarding choosing your battles and looking into the more socially aware side, how much are you focusing on making the robot socially aware? Because you mentioned things like the robot making the doctors feel happier and the staff happier. How are you focusing on that, and how much are you planning to focus on that?
Yeah, it's a good question. This one's a tough one where when you're down to the wire and trying to figure out which feature makes it into sprint planning, we think about, the way we think about it is really thinking about how people and HRI go into our system from the very beginning. We do things like body storming and working out storyboarding with a robot, and then we build into that, or into the feature development, all the pieces around different aspects of, okay, well, should the robot communicate here? Where's the transparency? And we really think about it from that perspective. Otherwise, if you keep it as a separate roadmap entirely, it will never get pulled in and will never get prioritized. So I'm not sure if that answered it exactly, but yeah.
Okay, thank you. Because of the time cycle, one quick question from you.
Hi, thanks for the great talk. How important do you think it's been for Moxie to have a face?
Great question. I think it's been, well, I mean, I have an HRI background and I still was surprised at how much it made a difference. We get so many selfie requests and nurses just love the robot. We were just at one of the nursing conferences and we brought Moxie there, and just the floods of people that went to our booth being like, I was trying to find the robot. It's so cute, so adorable. And it's hard to measure, but it's definitely something about the fact that the robot has a face, can react, and can do things like change into hard eyes with its face, that really has made people connect with the robot. And that connection has been crucial for having people feel like Moxie's one of their teammates.
So yeah, thank you.
Okay, thank you very much. Thank you, Vivian, for this nice talk. Everybody, please give her a big hand.